Tuesday is always RUMP day at OFC, and this year did not disappoint. The room was packed, as I had never seen before, and we discussed the need or not for new materials in Silicon Photonics. And the conclusion is that we need to be more inclusive. Thanks to IMEC Green Bogaerts for your vision. Silicon Photonics has gone LGBTQI+. Lithium Niobate, Graphene, Barium Titanate, transfer printing, quantum dots, indium phosphide, and the plus includes polymer and plasmonics. But seriously, on the show floor of this year's OFC, the overall theme is capacity. How much data per second can be processed on a single chip? And we've all seen the light counting slide from Nvidia saying they can't wait 10 years for a solution. They need it now. I think this explains why we are all amazed by the announcement here by Peter Winzer's team at Nubis Communications, promising 1.6 terabits per second on a single photonic chip. Have we all gone mad? And when I thought I'd seen everything, just walking around the exhibition, I got stopped by my friend Joseph Ben Ezra, CTO at Newphotonics from Israel. And he says, Jose, we want to show you our secret live demo at the Credo booth. Please tell us what you think. Honestly, I had no idea what to expect. And then I see what I believe is the biggest revolution at this show. This can only happen at OFC. Witness it yourself. Newphotonics has achieved 4 times 224 gig on a single silicon photonic chip. They are using a standard silicon photonic modulators. No lithium niobate, no polymer, no BTO, and what's even crazier, they use time division multiplexing. Hence, they could still multiplex in frequency and multiply their capacity beyond that. Do not take my word for it. Just look at this. Thank you very much, Joseph, for being with us. What did you bring to OFC this year?
We are demonstrating 224 gigabit per second transmission on the same lane.
224 gigabit per second transmission, one unique photonic chip, and if you come here, over here, you can see the structure. Could you comment on us? What is the architecture that we have here?
Okay, the architecture that we are collaborating with Credo. We are taking services from Credo. You can see 8 lines, actually 8 112 gigabit per second lines are coming to our optical engine, and we are capable actually to double the data rate at the output of the system. And as you can see, the data is transmitted over 2 kilometers of fiber, and actually even the dispersion is managed in optical domain, and finally you can see very clean signal detected after 2 kilometers of propagation. Actually, in this box we have photodiode even without transimpedance amplifier, so we can increase also up to 10 kilometers. It can transmit these high data rates up to 10 kilometers of distance.
You know what is most impressive for me? In the last years, people are saying that to reach these speeds, we need to go to new materials added to silicon photonics. People are talking about BTO, are talking about polymer, are talking about plasmonics, lithium niobate. Did you need any of those?
We don't need it because actually these data rates are achieved from the single light source. And actually what we are doing, we are using not so sophisticated modulators and balanced detectors and etc. We are using the regular standard optical devices. Yes, actually we can, in parallel to this time domain multiplexing, we can also use the frequency domain multiplexing. So if we will achieve 800 gigabit per second transmission using one single source, we can combine both time and frequency division multiplexing and achieve more higher data rates with very simple architecture.
Stop. That's the only bit I can share publicly without getting in trouble. For how it's done, you need to talk to them directly. Tell them I sent you. But wow, I always respect companies willing to do live demos at exhibitions. Press releases are fine, nice pictures are beautiful, but in photonics, touching is believing.